Hello everyone. In this video, we talk about contingency table. A contingency table provides a way of summarizing data that can facilitate calculating probabilities. The table helps in determining conditional probabilities easily. The contingency table displays sample values in relation to two or more different variables that may be dependent or contingent on one another. Here we will use a scenario to go through some probability questions. Let's take a look at this scenario. Many drivers canceled their car insurance as the unemployment rate increased. Sample data representative of car insurance coverage for individuals 18 years of age and older are shown in the contingency table below. Let's take a look at the table. In our sample, for the drivers between age 18 to 34, 125 of them purchased car insurance, and 32 of them do not have car insurance. And then for drivers age 35 and over, in our sample, 300 of them purchased car insurance, and 43 of them do not have car insurance. The next step in dealing with contingency table is to get the total. We need to calculate the row total as well as the column total, including the total sample size here. For the drivers aged between 18 and 34, we have 125 drivers purchase car insurance and 32 do not. So in total, there are altogether 157 drivers between age 18 and 34. And then for drivers 35 and over of age, we have a total of 343 of them in our sample. And then for the column total, the first column indicates the number of drivers who purchased car insurance in the sample. So here we have 125 plus 300, we get 425 drivers purchased car insurance in the sample. And then the number of drivers do not have car insurance, we have 75 of them. Altogether in our sample, we have 500 drivers. And then I will define the event. I will define event A for the drivers whose age between 18 and 34, and define event B for drivers with age 35 and over. And then I'll denote event C, where the drivers purchase car insurance. And then for the drivers who do not have car insurance, I denote this as C dash, the complement of event C. If a driver is randomly selected, find the probability that the driver has car insurance coverage. Can you do the calculations? Okay, so here what we need to get is the probability of C. C denotes the driver has car insurance coverage. Here we have the probability of C equals NC over NS. The number of drivers who has car insurance over the total number of drivers in our sample. So here we have NC equals 425, and then NS, the sample size, is 500. So the probability of C, the probability that drivers has car insurance coverage, equals 425 divided by 500, equals 0.85. Let's take a look at another example. If a driver is randomly selected, find the probability that the driver is in the 18 to 34 age group. So now we are interested in event A, the drivers between age 18 and 34. So here we need to get the probability of A equals the number of drivers in this age range divided by the sample size. The number of drivers in this age range is 157, and then the sample size is 500. So we have the probability of A equals 157 divided by 500. We get the probability that the driver is in the 18 to 34 age group is 0.314. Let's take a look at another question. If a driver is randomly selected, find the probability that the driver has car insurance coverage and below age 35. In this question, we are interested in the probability that the driver has car insurance, event C, and the driver is below age 35, which corresponds to event A. This is equal to the number of drivers in our sample that has car insurance coverage as well as the driver is below age 35. So this is denoted by the symbol N of the intersection of C and A. So what is this value? So we have event C, and then we have event A. We need to find the intersection of these two events. So the corresponding numbers is 125. Divided by the sample size, NS, equals 500. Then we can compute the probability. The probability is equals 125 divided by 500. We get 0.25. So the probability that the driver has car insurance coverage and below age 35 is 0.25. The next question. If a driver is randomly selected, find the probability that the driver does not have car insurance coverage or below age 35. Which numbers in the table are relevant according to this question? We want to get the probability that the driver does not have car insurance coverage or the driver is below age 35. So in terms of symbol, we need to get the probability P of the union of C prime and A. Okay, C prime is the complement of event C, where the event C prime denotes the driver do not have car insurance. And then event A corresponds to the driver whose age is between 18 to 34. We need to find the union of two events. Then make use of the addition rule. So we have to find the total number of drivers who do not have car insurance or below age 35. So here we have 75 of them do not have car insurance and 157 of the drivers whose age is between 18 and 34. How do we obtain the number of the union of C prime and A? By the additional rules, the number of the union of C prime and A equals the number of C prime plus the number of A minus the number of the intersection of C prime and A. So the number of drivers corresponds to the event C prime is 75. And the number of drivers corresponds to event A between age 18 and 34 is 157. And then minus the intersection of the two events where the numbers equals 32. And then the result of this divided by the sample size 500, we can get the desired probability. All right, so here we have 75 plus 157 minus 32, we get 200. This is the number of drivers corresponds to the union of event C prime and A. This is the number of drivers in our sample that do not have car insurance coverage or the driver is below age 35. And then divided by 500, we get the probability 0.4. Let's move on to the next one. If a driver is randomly selected, find the probability that the driver has car insurance coverage given that the driver is 35 and over. In this question, we need to find a conditional probability. Here we are given that the driver is 35 and over. Okay, so in probability symbols, we need to find the probability of event C given event B has occurred. Given that the driver is 35 and over, what is the probability that the driver has car insurance coverage? Apply the conditional probability formula. So we get the number of the intersection of event C and event B divided by the total number of drivers corresponds to event B. Okay, so only event B is relevant. So we don't need the information of event A or the corresponding column total. Okay, so in this question, we are only interested in the 343 drivers whose age is 35 and over. And then from this reduced sample space, we want to find the probability that the driver has car insurance coverage. So out of these 343 drivers, 300 of them has car insurance coverage. So the result is the probability that the driver has car insurance coverage given that the driver is 35 and over. So directly with these two numbers, we get 300 and then divided by 343. And this is the desired probability asked in the question. And the probability of this is 0.8746. Let's take a look at another question related to conditional probability. If a driver is randomly selected, find the probability that the driver is in the 18 to 34 age group, given that the driver does not have car insurance coverage. Okay, so here we want to find the probability of event A given the event C prime. So we are given that the driver does not have car insurance coverage. So the drivers that has car insurance are not relevant in our calculation. The driver that do not have car insurance is the reduced sample space. And from this reduced sample space, we want to find the probability that the driver is in the 18 to 34 age group. So the number of drivers in this age group is 32 out of a total of 75 drivers. These 75 drivers is the condition that we are given that the driver does not have car insurance coverage. So the desired probability is 32 over 75 equals 0.4267. Okay, so let's take a look at the next question. Here we want to deal with independence. We want to check whether the event drivers whose age between 18 to 34 and the event that the drivers have car insurance are independent or not. So recall how we check independence. Here I make use of the condition that the probability of A times probability of C equals probability of A and C. If this condition holds, then we can say that the two events are independent. So this is what we need to check. Okay, what is the probability of A? The probability of A equals 157 divided by 500. This is the probability that the drivers is in the age group between 18 and 34. And then the probability of C corresponds to the probability that the drivers have car insurance. And the expression for C is 425 divided by 500. Upon calculation, we get the probability of A times the probability of C equals 0.2669. Let's take a look at the right-hand side, the probability of A and C. This is the probability that the drivers is between age 18 and 34, and the driver also have car insurance. The corresponding probability equals 125 divided by 500. Upon calculation, we get 0.25. And then check whether the two probabilities that we have calculated are the same or not. On the left-hand side, we have 0.2669. And then on the right-hand side, we have 0.25. The probabilities are not the same. And therefore, we can conclude that the two events are not independent. This concludes the section of contingency table. Thank you for watching. And in the next video, we will talk about the law of total probabilities.